All right, here we have the 2.1 handout, propositional logic and translation. First we'll talk about propositional logic, and then we'll move through to the second and third page. And third page you'll get a little practice translating from English into the formal language propositional logic, or PL for short. First we have here this distinction between meta-language and object language. I'll leave it to you to read all about it, but I'll just make a few comments about this that don't appear on the handout. So it mentions that we use English star as our metalanguage, and English star is just English supplemented with metalinguistic variables and set theoretic notation. English star is actually also English plus all of the formulas and symbols of PL. We need all of those formulas and symbols of PL so that we can name formulas of PL and say things about them. In fact, this distinction between metalanguage and object language is very closely related to the use-mention distinction discussed in Week 1, Lecture 2. I think an example will help here. Here we have the sentence, the expression, we would read this, the expression A arrow B is a sentence of PL. So this string of symbols, apparently A followed by the arrow followed by the letter B, is a sentence of PL. What we have here is a case of mentioning. I'm of course not using this sentence of PL, but rather what we have within the single quotes is the name of the conditional sentence A arrow B, and the name of that sentence appears in the subject position of this sentence of English star. So English star has to be able to have names of PL sentences in order to say things about PL sentences, like this claim here, the expression A arrow B is a sentence of PL. This is a true claim, and the name of this expression appears in the subject position of this sentence. The situation is actually very much the same as a normal sentence of English. Of course, Frege the man himself is not occupying the subject position of this sentence. We need a noun to do that, so we have Frege's name, which occupies the subject position of this sentence. Similarly, we don't have the sentence itself occupying the subject position of this sentence. We have rather the name of the sentence. That's what mentioning a sentence does. In order to name any given sentence of PL, I have to be able to write the sentence itself in English star. So English star is actually a little bit more robust and rich than maybe I originally imply on the handout. Oh, hi. So let's move on to the syntax of PL. I didn't realize it was recording there for a minute. Here we have the entirety of the syntactic rules for creating essentially grammatically correct sentences of PL. Everything you see here between these two horizontal lines is all that there is to the syntax of PL, all that there is to the grammatical rules for the language propositional logic. In fact, less than that, because all of this is just extra notes, commentary about the syntax. Really, we just have the symbols here, and then the actual grammatical rules here, just these three rules. And then we've got a couple of abbreviation rules to discuss. So this is perhaps the most important part of today's video lecture here, the syntax of PL. What we're going to want to get a sense of is what counts as a well-formed formula of PL and what doesn't. We'll start up here with the non-logical components of PL. Those are just the basic propositions. A, B, C through Z, and subscripts A2, B2, C2. Notice we have positive integers as subscripts from 2 onto any finite integer that we could write off to the right as subscript of a letter. Mostly, though, we'll only have need to use A, B, C, that is A through Z. Just the letters without subscripts of the alphabet. But if we ever needed more, we could add these subscripts so that technically there are infinitely many basic propositions of PL. And these are the non-logical components. Together, the non-logical components and the logical components constitute the vocabulary of PL. So the other half of the vocabulary here, just these 5 connectives. Neg symbol for not, it behaves like the English not. The caret symbol here behaves like the English and. The wedge for or. The arrow for if then. And the double arrow for biconditional. If you were exposed to other connectives in another logic course, that's fine. You'll just have to memorize these new symbols, which will mean the same thing that they meant in your other logic class. And lastly, we have the punctuation symbols, the auxiliary components, punctuation left parenthesis and right parenthesis. Note that the commas used to separate symbols here in all of these portions of the symbols of PL, the commas are not symbols of PL. We're just using those to separate. So all of these information about the symbols was written in the metalanguage English star. The metalanguage contains auxiliary symbols like commas, whereas PL, the only auxiliary symbols are left parenthesis and right parenthesis. Okay, and let's see, a couple notes here. This note here about the well-formed formula variables, just to be clear, these letters from the Greek alphabet, alpha, beta, gamma, delta, are acting as our meta-variables, our well-formed formula variables in PL. This was the choice of our author, and so I'll try to utilize all of his symbology in my lectures and handouts. But these behave just the same as P, lowercase p, q, and r might have behaved in another logic course that you took, or maybe another philosophy course where you were introduced to statement variables or propositional variables, p, q, r, s, t. Maybe sometimes you see phi and psi, or in the modern pronunciation, phi and psi. These are other Greek capital, well, usually they'll be in the capital form, but these are other Greek letters later in the alphabet. At any rate, our metalinguistic variables, be sure that you kind of familiarize yourself with alpha, beta, gamma, delta. You'll see a lot of them in lectures. Okay, so down to the formation rules. Those are our symbols, but we want to know what to do with them in order to make grammatically correct sentences of this little symbolic, this little formal language, PL. The formation rules. The first rule tells us that basic propositions are grammatically correct sentences. They're well-formed formulas, WFFs or WOOFs for short. So these are all well-formed formulas on their own. If that's the case, then that is a well-formed formula, A, on its own. And it says that all of the basic propositions are well-formed formulas. We have subscripts sometimes too, right? So A sub 235 would be a well-formed formula. So would B10, or I guess maybe B12 for your vitamins. This would be a well-formed formula on its own. These are all well-formed formulas. What about, here's a little quiz question. You can pause it if you need, pause the video if you need to think about it. What about A sub 1? Is that a well-formed formula of PL? I'll go ahead and answer it right away though. Let's go down and peek. You didn't know that I did this, did you? I scrolled up here. I found extra space in this program to write notes, so I don't have to write on the handout. It's a little bit more convenient. It says here that basic propositions are well-formed formulas, and our parameters here, the basic propositions, include A through Z, and A2 through Z2, A3 through Z3. Nowhere do I see A1, B1, or C1. Really, this set A through Z are playing the role of A1, B1, C1, and so on. But we don't have A1, B1, C1 as well-formed formulas. So this is not a well-formed formula. All right, so that's rule one. You have a sense, I hope. Obviously Z 305 would count as a well-formed formula. That's a Z, a very sloppy Z. Let's see what else counts as a well-formed formula. Rule 2. If alpha and beta, so these are well-formed formula variables, so we would expect to see this here. If alpha and beta, we'd expect to see this, are well-formed formulas. If alpha and beta are well-formed formulas, then so are neg alpha. Of course, neg beta would also count, but the content of alpha, remember this is a variable, so the content of alpha, for all we know, is the same as the content of beta, so we don't have to write that. It would be sort of redundant. Neg beta would also be a well-formed formula. Anyway, neg alpha, left parenthesis, alpha, caret, beta, right parenthesis, is a well-formed formula. And then the whole string of symbols, left parenthesis, alpha, wedge, beta, right parenthesis, is a well-formed formula. And the same for alpha arrow beta and alpha double arrow beta when encapsulated in parentheses like this. That's what Rule 2 tells us. So we'll want to walk through Rule 2 step by step in detail and look at a bunch of examples. We'll do that in just a second. Let me point this out. Rule 3 says nothing else is a well-formed formula. This is our closure rule. Here we have what's called the base clause, or the base rule, that establishes a base of propositions by simply calling our attention to the basic propositions here. So we have an infinite base already of propositions. And then Rule 2 here is sometimes called the recursive clause or the recursive rule. And it can be applied and reapplied with our base clause over and over again to create huge, complicated, well-formed formulas. So we really have, even if we only had a finite number of basic propositions, say we had A, B, and C were our basic propositions, we'd still get an infinity of propositions by simply applying and reapplying Rule 2 recursively over and over again. But if you grab a chair or a table or a person or a sentence like Frege is a man and ask, is that a well-formed formula? All of those things get ruled out by Rule 3. Rules 1 and 2 won't tell us whether tables and chairs count as formulas. They won't tell us whether sentences of English count as formulas. But 3 answers all those questions for us. The answer is always no, unless it was a formula constructed by Rules 1 and 2. Okay, and then we have abbreviation rules. We'll get to those in a second. Let's look at a few examples. Let's start with neg alpha. Neg alpha says I can take any well-formed formula and put the neg symbol in front of it, and I'll get a well-formed formula. So we already said that A here is a well-formed formula. Apparently then neg A is a well-formed formula. And neg A 235, neg Z 305, and so on. These are all well-formed formulas. Here's a quick question. We noticed perhaps that we're supposed to put parentheses. That we're supposed to put parentheses around formulas. It took them away. There's no way to redo. That's all right. We had something like the following list of formulas that we were looking at. So we have some in our list here that are well-formed formulas and some that are not. We saw that we're supposed to put parentheses around some of these formulas, but what about negations? The question is that a well-formed formula? Is, say, something simple like C, surrounded by parentheses, a well-formed formula? And if it is, then is maybe that a well-formed formula? Well, let's go ahead and take a peek again. Rule 1 tells me, Rule 2.1 tells me that basic propositions are well-formed formulas. And I look up at basic propositions and none of these has parentheses around it. If that's the case, then a formula like this is not a well-formed formula. If that's the case, since this here is not a well-formed formula, then putting a neg in front of it doesn't change it into a well-formed formula. It just puts a neg in front of a bad non-formula. So this is not a well-formed formula either. What about this one here, though? Is this a well-formed formula? Well, the rules were written very exactly. And you'll notice for the neg symbol, we don't add parentheses anywhere on the outside of the neg symbol or on the inside for the A. We take whatever parentheses were added already, suppose we had a conjunction, we'd have parentheses, and we add the negation to the formula that we were already given. If that's the case, then this too is not a well-formed formula. A 200, what was it, 233 is a well-formed formula. And since it is, I can attach a neg symbol to it, and that's a well-formed formula. But if I were to put parentheses around the whole thing, that would not be a well-formed formula. All right, so there's rule 2.2, 2.2 neg, we could call that. Let's go to rule 2.2 caret, or conj. 2.2 caret says that conjunctions like this are well-formed formulas. Left parenthesis, alpha, caret, beta, right parenthesis. If that's the case, I should be able to take any well-formed formula, any two well-formed formulae, or formulas, and conjoin them with a caret. So I can take, let's take A237 and conjoin it with Z305. Or actually, we have neg not A237 and conjoin it with not Z305. Now we can ask, here's a little quiz question, is that a well-formed formula? If you need to think about it, think about it. I'll give you the answer. No, it's not. I need parentheses around the whole thing. Why do I now need to add parentheses? Well, the rule for conjunction told us that we needed parentheses around our conjunctions. We don't need to add new parentheses for the negation, but I do need to add them when I form a conjunction. So there's a well-formed formula. What about A and B? Is that a well-formed formula? No. I need parentheses around the whole thing. What about something like this? A and parentheses B. That is not a well-formed formula either. Okay, so we've got a sense of how to make conjunctions according to the rule. What about then disjunctions? Well, we formulate disjunctions in a similar fashion, except instead of using the caret, we use the wedge. So I can take any well-formed formula and any other well-formed formula and put the two in a disjunction together with a wedge between them. So we already said that this is a well-formed formula here, and we said that this is a well-formed formula here. So apparently, I can form their disjunction. I'll need extra room for that, like so. Am I done? Is that a well-formed formula? No. I've got to add now parentheses for the whole disjunction. This parenthesis here, is the left parenthesis of this conjunction, and here's the right parenthesis for the conjunction. Then this left parenthesis is for this conjunction, and the right parenthesis here is for the conjunction. Now, this left parenthesis is for this disjunction, and the right parenthesis is also for the disjunction. We could have simpler disjunctions, of course, as well. We already said that neg Z305 is a well-formed formula, and we know that F is a well-formed formula because it's part of our alphabet. It's one of our non-logical symbols, our basic propositions. So we put parentheses around the whole thing. That's a well-formed formula. Okay, so this is a little bit simpler disjunction. I can do the same rules then for the conditional, the arrow, and the same sort of rule where I take any two well-formed formulas, put between them an arrow, and surround it by parentheses. I can do the same thing with a double arrow. So let's do both of those together now and look at just a couple of examples here. We've got this really big formula, and if we wanted, then we could take it and combine with it. Of course, this doesn't follow logically or something. This isn't like a logical operation. We're just making sentences of the language. They're not valid or true or false. They don't factor into any valid argument that we're concerned with right now anyway. We're just making sentences according to the rules. Let's take this sentence here, A and B, and make that the consequent of our new conditional. And so we get A and B. And am I done yet? No, that's not a well-formed formula. I need parentheses for the whole arrow. And if I wanted, I could add maybe a couple negations. That's a good question. Is that a well-formed formula? Can I add two negations like that? For instance, that's a well-formed formula. So I know that's a well-formed formula. If that's a well-formed formula, shouldn't I be able to go like this? And if that's a well-formed formula, is that a well-formed formula too? And what if I just add a few more? Is this a well-formed formula? And yes, this is a well-formed formula. And yes, this is fine. We can add two negations here. It's redundant, and it turns out that this is logically equivalent to the whole formula minus the two negations, at least in classical logic, the sort of logic that we'll be learning this semester. But this is a well-formed formula. Okay, and we know that this here is a well-formed formula, and if we wanted, we could add a biconditional to it as well. Let's put it off to the left this time, just for kicks. So we draw our double arrow off to the left, and what shall we join to this disjunction? We could join something. Let's join D 10,002. D 10,002. D 10,002 if and only if either not Z 305 or F. And we have to put parentheses around the whole thing to get a well-formed formula. So these are all well-formed formulas except for the ones that I've put X's through, and the surprising one perhaps here, we can have many, many negations, and I could add more negations here if I wanted. These are all still well-formed formulas. I can take any well-formed formula and add a negation to it. And I can take any two well-formed formulas and join them together in a disjunction, a conjunction, or a conditional, or what have you. So, the formation rules. Those are some example well-formed formulas. That was the important part of this lecture right there. Notice, don't forget to read on your own. There's a footnote to this handout here about basic propositions, about parameters and what parameters are kind of doing. You should read that. And there's another footnote somewhere else. No, there's no other footnote in this handout. But there is one last bit of vocabulary that we need to talk about real quick. The main connective and the minor connective. The main connective is the connective with the widest scope. It's governing all subformulas in a formula in a compound statement. And the minor connective, there's oftentimes many minor connectives, so there's always only one main connective of a formula. The minor connectives are every connective in a compound statement or proposition except the main connective or a compound formula. So let's go up here and take a peek real quick at these formulas that we ended up writing. And we want to look at, say, this one and ask what's its main connective. It's the main connective that's governing all the subformulas. D, 10,002 is a subformula. This disjunction is a subformula. It's a formula all on its own. And it has two subformulas, F as the right disjunct, and not Z305 is another subformula. Not Z305 has a subformula, just Z305. So we sort of can build up from the basic proposition Z305 to not Z305. That's a whole left disjunct, and F. There's our whole disjunction. And we're building out to our main connective. And it looks like this is the whole right bicond in our biconditional, the whole right part of our biconditional. I say bicond. And the left bicond is D 10,002. That leaves this double arrow here. The biconditional then is our main connective. So if someone asked me what kind of statement is this, I'd call it a biconditional. We name it according to its main operator. It's the biconditional. Let's look at this formula here. What's its main connective? We can sort of start some of the smallest. We'll start with our basic propositions. And let's start over here on the right if we want. We can start on the left. Let's start here. A is a basic proposition, B is. So A and B is a formula made out of A as one conjunct and B as the other conjunct. But this whole conjunction here apparently is the consequent of a conditional. A conditional whose antecedent starts with this right parenthesis, and this goes back, if we count our inner parentheses, 1, 2, 3, 4 for the two disjunctions, and then right over here, here's the left parenthesis for apparently this disjunction. This disjunction has a conjunction as one disjunct and another conjunction as its other disjunct, left disjunct, and the whole disjunction is the antecedent of this conditional. And then this conditional has its parentheses. Here's one parenthesis and here's another parenthesis. But then governing this whole conditional here, we have this neg symbol. But then governing this whole negation here, negation of a conditional, we have this neg symbol. And governing this, we have this neg symbol. So what's the main operator? It's right here. In that case, we'd call this a negation. So this here was a negation. That's its main operator. The rest are all minor operators. The main operator here, negation. Main operator here, the only operator, conjunction. Main operator here, it's negation, obviously, but which one? Well, the outermost one, the one that governs all the rest. This is the main operator. So this is a negation as well. All right, main and minor operators. I almost forgot. We have these two abbreviation rules right here to discuss real quick. To avoid clutter, when parentheses are the outermost part of a compound, those outermost parentheses may be removed. So a lot of the formulas that I asked questions about earlier, is this a well-formed formula? Prior to putting the parentheses on the outside, we would call a well-formed formula. It's just not a complete well-formed formula or a strict well-formed formula. It's an abbreviation, according to abbreviation rule 1. And the second abbreviation, for clarity, we may alternate between parentheses, brackets, and braces. Braces are just those squiggly brackets. Parentheses look like this. Brackets are square, like so. And braces or sometimes curly brackets, they're called, look like that. We can alternate at each level in a compound proposition. So let's look at our examples up above then and see what we might do to abbreviate some of these. Well, first of all, I can abbreviate, if I want, I can abbreviate alpha and beta, or sorry, not alpha and beta, A and B. We're right here now, by the way. A and B, I just peeled off those outermost parentheses. This is a well-formed formula. It's just not a strict well-formed formula, it's an abbreviation. I could do that. Here, leftmost parenthesis and the rightmost parenthesis are the outermost parts of the formula. So if I wanted, I could peel those off, and the result here is not ambiguous. So it too is a well-formed formula. It's just an abbreviated one. Now what about this big formula here? Notice you might think we could peel off this one and peel off this one. But what would happen if we did that? If we did do that, these negations, this negation, would attach to this parenthesis right here. If that's the case, this parenthesis works for this whole disjunction. So instead of negating the whole conditional, the meaning would change. We'd then just be negating the antecedent of the conditional. So if I peeled these off, I'd change the meaning of the formula. The reason is, this is not the outermost part of the formula. The outermost part of this formula is way out here. Since it's not the outermost part, I can't peel it off, according to my abbreviation rule. Okay, so hopefully you got a sense of how to apply these formation rules and the abbreviation rules. We're not quite done with our abbreviation rules yet, though, because our second abbreviation rule tells me that I should alternate at different levels in a compound formula between parentheses, square brackets, and squiggly brackets. So let's do that just with this big formula here. It's the only one we have left that we can alternate with. So let's start with our smallest subformulas that are themselves compounds. We have the negations, but those don't require parentheses. Let's look at this conjunction here then. We've got parenthesis here and a parenthesis here. This conjunction is the left disjunct in this disjunction. Let's then take the disjunction and change its parenthesis. That's the next level of this compound, and take this parenthesis and change it into square brackets. So to do that, we'll just have to delete here these two parentheses, and then we'll try to squeeze square brackets in here real quick. Okay, so now let's see, I've got a square bracket as the antecedent of this conditional. I personally like it when my conditionals look the same on both parts, so that the antecedent, if it's covered in a square brackets, will cover the consequent in square brackets as well, make it easier to read. So here I've deleted the parentheses around the consequent, and we'll just make those match the antecedent. Now I know what the two parts of my conditional are: the antecedent here in square brackets, the consequent here in square brackets. Now the only other thing to change is another set of parentheses. We said that we could alternate between parentheses, square brackets, and squiggly brackets, or braces. So let's go ahead and delete these parentheses and replace them with squiggly brackets. So if I can squeeze my squiggly brackets in here, now there's one, that one's easy, this one is a little harder. There we go. And there we have a formula that is well formed as an abbreviation. Even though we didn't get to take out these squiggly brackets, it still counts as an abbreviation of the original well-formed formula, and we've had a chance to practice using the first abbreviation rule here, peeling off the outermost parentheses, and the second abbreviation rule here, alternating between parentheses and then square brackets, and then braces at each level of the compound. Okay, on to page 2. All right, that's it for page 1 of the handout. Pages 2 and 3 I can do real quick. Page 2, this should look somewhat familiar. One of the pages on the week 1 lecture 2 handout talked about the English connectives. What this page of our handout here is doing is connecting those English connectives to our PL connectives. So the English connective not, in all of its forms, corresponds to the single neg symbol. It's kind of nice. You'll find that the stumbling block in a lot of what we do this semester comes from English. English is nice because it's a natural language, so it has tremendous expressive power. We have all these different ways of saying not, all of these different ways of saying and then a whole bunch of other ways of saying and, different ways of saying or, and a whole bunch of ways of saying if, then. But we have just one way of saying not in PL, so it simplifies things for us a bit. Just one way of saying and that's the conjunction, the caret symbol. Just one way of saying or, just one way of saying if, then. And it looks like I've got a little footnote here. Note, this is not a translation into PL proper, for we are using meta variables, alpha and beta, in each of these translations. The result is a propositional form that is also known as an abstract proposition or propositional function, and not a proposition or a well-formed formula. So here I'm just giving you the form of the English sentence negation of the negation form, and into the form of a PL negation. We could give particular sentences by saying, it's not the case that the earth is flat, and then we translate that into something like neg f, standing for the earth is flat. And that would give us the translation of particular English sentence into a particular PL sentence or formula. But here we're just sort of giving you the general form of each of these sentence types and how they correspond between English sentence types and PL sentence types. So if you're ever asked to translate English sentences, and you will be, in fact the next page of this handout you'll be asked to do just that, you can use this page of this handout as sort of a guide, a helpful key. If you find the expression only if and you forget how does this expression only if work, does it mean the same thing as if, or is it more helpful for me to think of only if as meaning then? Well, if you think of only if as signifying that what comes before it is the antecedent and what comes after it is the consequent, maybe you should think of only if as meaning something like then. So this is A, then B. In other words, if A, then B. Alpha. Alpha only if. Beta, then is just alpha arrow beta. All of these variations here on the left get symbolized the same way on the right. If you want to know how to symbolize beta arrow alpha, you just swap the alpha and beta positions in all of the examples. All right, so that's that. Use this as a really helpful key for translating English into PL. All right, the last page of our handout here is a little exercise. I'll let you do this on your own, and I'll post an extra PDF file to Files in a little while with the answers to this written in, but I'll just go ahead and show you how we might proceed to answer one of these. Let's do number 5 here. We've already got the example one finished. I'm a bachelor unless I am married. I was told to use the wedge for unless, so I translated it as B wedge M, and you'll notice I peeled off my outermost parentheses and went with my abbreviated formula right here. Nice and clear, no ambiguity results, so that seems good. We'll do number 5. Mares eat oats and does eat oats and little lambs eat ivy. That's how you'd say that. This is from an old song. Mares eat oats and does eat oats and little lambs eat ivy. When the song's sung, you really can't understand what the people are saying. I think that's the silliness of the song. It sounds like gibberish. At any rate, we would go ahead and translate this into PL as so. We've been given the glossary here. Treat capital M as standing for mares eat oats. D is standing for does eat oats. It doesn't say does, it says does. And L for little lambs eat ivy. And we've got and here, whoops. And we've got another and here. So it looks like we've got sort of two conjunctions working together, and we end up with something that maybe looks like this. M, mares eat oats, and does eat oats, that's D. And little lambs eat ivy, that's L. Now, the question is this a well-formed formula? M caret D caret L. Well, according to our rules, I need parentheses strictly, and our abbreviation rules tell me that I can peel off the outermost parentheses, but it doesn't tell me that I can peel off all of the parentheses. So we have to sort of decide then. The strict formula would maybe look something like this. We might go, let's group mares eat oats and does eat oats. Since they're both eating the same thing, there seems to be a special similarity between M and D. And that's our completed translation right there. But to make it official, we'd want to put parentheses around the whole thing. However, I said that we could use abbreviations here, so we could peel those right back off. And there we have a correct answer. If you're wondering, could you have grouped D and L and put those in parentheses instead and left M hanging? You could have done that. Technically, that would say the same thing as this. Order doesn't matter with the conjuncts in a conjunction, nor does really the grouping. If the only thing you have is a big conjunction and every single subformula is also a conjunction, then how you group technically won't affect the truth value of the whole proposition. Generally, though, we'll try to decide where to put parentheses based on information in the English sentence itself. The information I chose to attach to was that mares are eating the same thing that does are eating. Usually, we'll have better clues than that. That's kind of a guess on my part. If you wrote, say, though, an equivalent formula and you grouped D and L instead of M and D, I would accept that on an exam or on homework or whatever, quizzes. But usually we'll have better cues like commas and semicolons. If we look down, I think there's a good example down here somewhere here at number 15. Dale Cooper is a detective and Laura Palmer is a victim, semicolon, nevertheless, if the Black Lodge exists, then the owls are not what they seem. This one's kind of complicated. You have to write really small to fit it in here. But the semicolon tells me that what comes before it is really quite separate from what comes after it. So it looks like the main connective is going to be nevertheless, which, if you recall from page 2, is one of the many ways of saying and. So we'd use the caret, and that'll end up being our main connective. I'll let you figure out the rest. And go ahead and complete this on your own, and then compare your answers to the answers that I post later. Good luck.